Okay, we're reviewing multiplying matrices right now. On the way to the main job today is making sure you're good at all the little things like determinant of matrices. I bet you not many people remember that. And then inverse of matrices. And then what's called the identity matrix. You would think this would be like the multiplicative identity, because with normal numbers, if you multiply by 1, you get the same thing back. That's called a multiplicative identity. So if I have the number 8 and I times it by this special thing called the multiplicative identity, which is just 1, it stays the same. Just like if I add 0, that's called the additive identity. Well, this is an identity matrix that we're talking about. If I multiply by this, that's not the identity matrix. It won't keep the answer the same. You should have realized that this is a 2 by 2 and this is a 2 by 2, and since these match, the answer will be a 2 by 2. I'm doing a super quick review of multiplying matrices here. And now I'm going to slide it over, and the answer for this will be this spot right here is row 1, column 1. So I'm going to take row 1, column 1, multiply the 2 times the 1, and add it to the 1 times the 1, which would make 3. Raise your hand if you had a 3 up there. Awesome. So did my matrix stay exactly the same? No. Mr. EB, what did you get for the rest of them? 3 and then 1, 1. Raise your hand if you got the same thing as he did. Awesome. Then you know how to multiply matrices. If you don't, you're behind and you need to catch up. Okay, so the next step after this is, what is the identity matrix? Like, what could you have? Anybody have any theories on what we could multiply by that would keep it the same? Hold on, technical issues there. Well, if you're looking ahead in the notes, that's cheating, but anybody guesses? Yes? 1, 0, 0, 1. So yeah, if you multiply by that, you'll get the original back. That's called an identity matrix. What if the matrix is bigger though? Like, what if the matrix is like 3 by 3? Do you think it's that? Any guesses? If I told you that that much was right? Yes? Yeah, kind of diagonal. And you look at the 1s and you see it's like a diagonal of 1s. If you multiply by that, your matrix will stay the same. Okay. Now that's called an identity. That is totally different than an inverse. Here's why you might want to do an inverse someday. Would you agree that multiplying and dividing are kind of like opposites of each other? Do you know what the multiplicative inverse of 2 is? It's 1/2. It's an inverse. And that fixes it also. Get what I'm saying? Okay. Well then, what we need to do is learn how to use inverses like this You want to get rid of this to have x and y be alone. That's what you're doing to solve an equation, right? How do you think you get rid of the green circled matrix? Let me call him matrix A so it's easier to talk about him. Times by its inverse. Very good. That's why we need inverses. So then how do you find the inverse of this guy? It's a complicated formula. Write it down. 1 over the determinant. I'll remind you how to do that again in a minute. And you times by, these two get switched, flip-flopped, 5 and 1 instead of 1 and 5. And the last two things is, does anybody remember? I've got an amazing memory. Yes? They flip the signs on the other ones, negative and negative. What's negative 0? It's still 0. Negative 2, negative 2. There. If I only knew what the determinant was, it's some number there, and let's say it came out to 2. If the determinant was 2, I'd take 1/2 times all the things in the matrix, and I'd be done. Notice these two switched places. These two became opposites. And then if you could just remember determinant, we'd be fine. All right, so now how do we get the determinant of that matrix? The determinant was this times this. Anybody want to finish this? What do you think? Yeah, so 5 times 1 minus 2 times 0. And what is that? 5 minus 2. And what is that? 3. I think of the determinant as the thing that determines whether you'll have an inverse. Because remember how that other one was 1 over the determinant? Do you get if the determinant was ever 0, you'd have a problem. Can't have a 0 there. So if the determinant comes out to 0, you have determined there's no inverse. All right, so we just a second ago had this all set up with 1 over the determinant. Question? Oh, I did it again, didn't I? 2 times 0 is not 2. Dang it. What's 2 times 0? 0. So 5 minus 0 is 5. Oh, I wish you could have caught that earlier, but maybe you're raising your hand for a while. I just didn't notice. Thank you. All right, so 5 is the determinant. It's still determined that there is an inverse at least. If you have a decent short-term memory, you should be able to recreate this thing that we just did, except now we know the determinant. We just figured it out. Find the inverse. By doing that, reverse these two things. See if you can do it. What was the determinant? We just figured it out. 5. 1 over 5 times, these get reversed. These do opposites. There you go. Now don't get all confused because there's a fraction out front. It's just 1/5 times 5, which makes 1. Finish it. What did you get, sir? Yep. Yep. Yes. Could that have been done on a calculator? Yes. Both the determinant thing and the inverse thing could have been done on a calculator. And you might be saying, well, if you're going to show me that, why do you make me do it by hand? Well, number one, it's good for you to know what's happening. Number two, if the ACT test puts an M right here, the letter M, in a matrix, you could still solve and get your answer. Do you get that this would have just been 1/5 M, so it would have been either maybe M over 5 would have been right there? But your calculator couldn't do that. You could. You have to know the system. Same with permutations and combinations that you're going to learn next chapter in probability. There's a way for your calculator to do all probability problems, unless they throw a variable in it, then your calculator can't do it anymore. So you have to be ready for both on the ACT. All right, so let's use this same matrix, 1, 0, 2, 5, and let's put it in the calculator. Everybody grab your graphing calculator. Go to matrix A, change it to be 1, 0, 2, 5. I'll pause for a second while I pull that up. Okay, quick reminder in case you weren't paying attention the other day when we did this. If I want to put in this matrix here, 1, 0, 2, 5, then I go to matrix, which is right above that key. And then I see choices. Name, math, edit. I want edit. Edit the A matrix. Enter. It looks like the A matrix doesn't have the right numbers. Then I need to go fix it. And it wants me to put a 1 there. And a 0. And a 2. And a 5. Now this is the hardest part. You got to quit. That's weird, but it's true. Now, I got a nice clean screen. What do I want? I want determinant of A. Where do you think we find determinant again? Back in the matrix. So I'll go over here in the matrix. Math. Not edit. Math. And see DET right there? DET. And then I got it. Where am I going to find the matrices again? Back to the matrix menu. Oh, wait, I don't need to edit A. I just need to names A. I pick A. There, DETA. A lot of people ask me, do you have to complete the parentheses? No. If you really like completion and like, make everything perfect, you'll want to hit that end parentheses. On purpose, I'm going to not hit that, and it works fine anyways. Raise your hand if you got a 5. Okay. Now, do you get that's just part of the inverse? Now, the calculator does not need you to calculate the determinant for it. It can do the inverse right off the bat. So everybody, if we want this to happen, we're going to say A inverse. So everybody first put A up there. So we go back to the matrix menu, hit A and hit enter, and there it is. There's A, but don't hit enter again. We need to now do something to A. How do I say inverse with numbers? Yes. To the negative first power. There's a button for that. If you'd have said to the power of -1, it would have worked, but this is faster. That button, enter. And looky there. But, and this is a big but, on the test, we are going to require that you have your answers as fractions. There's a way to do that with one key. Or you can have to convert by hand, and your answer is probably going to have like 9 parts. You have to make them all into fractions. So anyway, I do this calculator way. It's a lot faster than hand converting them all. Because I know that one's 0.4, that's 4/10, which I'd have to reduce, 2/5. I could do it in my head, but here's the math way. Hit the math button. Enter, enter. Because the top one is changed to fraction. Enter, and then one more time. And there, look, they've all been changed to fractions. Math, enter, enter. By the way, that is handy on the ACT also. If you ever need to got a weird decimal and you want it to be a fraction or vice versa, the math button gets you either into fractions or out of fractions. Okay. Now, I'm going to go through the notes just super quick because I want you to see one really important slide. I'm going to pause for a second. Okay, I've got the lesson up now, and here are some things that I want you to see. This is that little formula again for finding an inverse. Notice that A and D switch around, and B and C become opposites. That's the determinant on the bottom. That's why the determinant isn't supposed to be 0. Okay. Next, there's a good one here. This one. I want to put this into your calculator and find, no, wait, I'm wrong. That's not it. My bad. The determinant and the inverse. There we go. There's the good follow-up finish. If you can do this without your calculator first, by hand in other words, then you should be able to do it all with the calculator and it should match. Then you understand everything so far. Okay? I'm going to pause the video for a second while you try to answer these two by hand and then with your calculator. If you get all of that, we're pretty much done. We'll finish up with one little interesting thought. You guys get -10 for the determinant. All right. Then the inverse. It's 1 over that, 1 over the determinant, 1 over -10, times, and then you just got to reverse these two, 4, -3, and I got to switch these two guys' signs. I think of it as opposite. Instead of saying make them negative, what if they already are negative? So you're switching their signs. You're doing opposite signs on these. Then I can do this in my head. -4/10. And then this times this. Positive, because there's two negatives. 2/10. Yeah, I should reduce those, and I will in a minute. And then -1/10. And last, that times that. Positive 3/10. And just to clarify, yes, I can reduce it. -2/5. 2/5. -1/10. 3/10. I think that's right. Can anybody verify that that is right? Oh. One-fifth, not 2/5. Thank you. I see it now. There we go. Now can we confirm that that is exactly right? Okay, awesome. Now you should also be able to put that all in the calculator. I'm going to leave that to you. If you do not know how, you should come up and ask me and I will show you. Okay? Because I don't want to bore the class because I think most of you got it down. You put in the matrix A, this guy right here, and you do DETA. And you would also do A -1 power. And that's what gets you your determinant of it and your inverse of it. Okay. I'm willing to help you one-on-one with that if you need it. All right. And then the last thought is, if this and this multiply out, which they will, and I'm going to save you some time. Let's say that they come out to this. What do you think that means? If you multiply out two things and they come out to 1, do you get that that means that they are for sure inverses of each other? Like if I had 5 and its inverse, 1/5, and I times them, they're going to make 1. Know what I mean? If these two are really inverses of each other, when you times them, it should equal the 1. But how do you say 1 in matrix world? Like that. All right. I checked thoroughly in first hour, and the worksheet for right now, the best problems for you to do are the evens. So I'm assigning the evens on tonight's worksheet. If you wish to do more for practice, it's a great idea. It's just you might not need any more to practice. Try the evens first. If you're feeling like there was any area that you kind of bad at because you looked at the key and, ooh, that wasn't good, maybe you should go back and do a couple of the odds. That's where you have to be responsible. But I think if you follow that method, do the ones I assign. If you ever need extras, go do some more. It's going to save you a lot of time. And I think I'm giving enough that you'll be okay. All right. So that's all I have for you for tonight and for the video.